I'll introduce myself. I'm Katarzyna Gajewska. I'm the project coordinator with SIREA, and I'd like to welcome you to today's SIREA Spotlight series. Our presentation is titled Emissions Reduction Through Wireless Switching, and it's going to be presented by Levven in collaboration with SAIT. The SIREA Spotlight series introduces new technologies and brings shared learnings from testbed projects as part of the Green Building Technologies Network. Today's presentation is one of 17 demonstration projects funded for innovation towards accelerating the adoption of low carbon solutions for buildings. Before we begin, I'll give a quick introduction to SIREA and make some acknowledgements. Next slide, please. SIREA is a not-for-profit organization that stands for Smart, Sustainable, Resilient Infrastructure Association. It has the mission to encourage the adoption of innovative green technologies for buildings. We work collaboratively with industry, post-secondary, and small-medium enterprises towards achieving this goal, which includes funding for demonstration projects like this one, a business growth program, and networking. To become a member and learn more, go to www.sirea.ca. Next slide, please. I think it's essential to do a land acknowledgement, so I have a map up of the treaty areas we're presenting from and where many of you are tuning in from. So if you could participate by locating the traditional territory that you're from and just pop it in the chat. I will recognize verbally that I am calling in from Treaty 7 and that SIREA operates also from Treaty 6 territories, which include the Blackfoot, the Siksika, the Piikani, the Kainai, and Tsuut'ina, the Stoney Nakoda First Nations, the Métis Nations of Alberta, Region 3, and the Cree, Saulteaux, Métis, and Nakota Sioux. Okay, next slide, please. Now I'd like to introduce our speakers. We have James Kierstead with us and Tyler Wilson. James Kierstead is the owner of Levven Electronics with an impressive background in business management, having brought previous business endeavors to lists such as Profit 100 and Alberta's Fast 50, as well as receiving international business and other local, provincial, and regional recognition and awards. Levven has a vision of making intelligent buildings available to everyone, focused on delivering technology and products to advantage new construction. Levven's promise is mobile devices, access and control of building infrastructure that lowers building costs, speeds construction up, and conserves building materials. So welcome, James. Next, we have Tyler. Tyler is a principal investigator with Smart Building Management in the Department of Applied Research and Innovation Services at the Southern Alberta Institute of Technology. With a background in IT and experience in sensor networks, monitoring systems, database management, and controls automation, he has been pivotal in the data analysis and systems performance monitoring on this project. Tyler has a diploma in IT computer systems, as well as a certificate in business intelligence, data analysis, and reporting, and has been a part of SAIT's Green Building Technologies research since 2015. Where he was previously leading technical activities, he is now managing research projects and activities in smart building management. Welcome, Tyler. With no further ado, I'll pass it off to our presenters.
Thanks very much, Kat. Well, hello, everyone. As you heard, my name is James Kierstead. I'm president of Levven Electronics, and I'm joined by my associate here, Tyler Wilson, principal investigator with SAIT. We're excited to share our project, Emissions Reduction Through Wireless Switching. At Levven, we believe that making home automation the new normal for everyone required us to rethink home control entirely, to find previously unrecognized value that is so great it could more than pay for the inclusion of smart controls in new construction. Here's a brief video describing how Levven controls would work for all new homes.
Our mission is to make homes more affordable to build, more affordable to purchase, and more affordable to operate. To this end, we've made two-component smart switching the lowest cost method for providing electrical controls in new homes today. This simple innovation reduces material and labor hours to lower the cost of constructing new homes, and it makes all the switches in the home smart. Shown here is a home under construction ready for the electrical rough-in. To rough in the electrical system with wired switches, electrical boxes are nailed to the studs where space is available. Wire is installed to each box to provide power for plugs, lights, ceiling fans, and other electric devices. And wire is installed between each switch box and the electrical device it will operate. Levven separated the switch into its two operating components: the rocker portion that people use every day, and the power control relay that switches the power. This simple innovation shortens construction schedules by at least 1 day, saves 35% of the building wire and boxes, and eliminates tasks for builder personnel and 6 different trades to make homes more affordable to build and purchase. Levven power controllers are installed at the trim or final stage of construction. They install inside the electrical box, connecting the power wires with the wires from the light, plug, or electrical device. Unlike switches of the past, Levven switches are free to be located where people need them. Levven switches mount directly on the surface after the walls are painted. Screwless trim plates snap onto the switch without tools, giving a compact, elegant designer's touch. Using the same wireless method that automotive key fobs use to lock and unlock car doors every day, switches send on, off, and dim commands wirelessly to power controllers. Levven portable switches put controls at your fingertips in places like bedside tables, shop benches, or the visor of a car. Levven switches can operate power controllers from a distance of 250 feet. Switches and power controllers can operate together in any combination, giving limitless switching flexibility. Up to 10 switches can operate a power controller, and any combination or quantity of power controllers can be operated by a switch. All the switches and switched electrical devices throughout the home can be controlled and configured from a mobile device or voice control with Amazon Alexa and Google Home. This increases the appraised value of the home while lowering costs. Levven Q and the Levven app connect mobile devices to operate and configure switches and power controllers throughout the home without programming, and this gives the homeowners the freedom to operate their home from anywhere in the world. Levven's business model is to match the electrical contractor's current price to the home builder. The electrical contractor does the electrical installation with Levven switches and controllers without increasing their price. Levven, making homes more affordable to build, purchase, and operate.
You're on mute, James.
Thank you.
No worries.
Currently, there is a lack of data to prove installation and operational savings across many green building technologies, and specifically for Levven controls. So we developed a sophisticated system to compare materials and labor savings of installing Levven wireless switches instead of conventionally wired switches. In pilots with stepper homes, they were able to reduce their trade labor time from 1.4 days to wire a traditionally conventionally installed switches, and down to 1 day for installing Levven controls. They also reported a 35% savings in wire, eliminated 34 switch boxes, 170 plus staples, connectors, and nailing plates during construction. But since most homes don't have energy monitoring, we couldn't identify what operational savings would be available with whole home controls like Levven. And the other challenge was, this was data that we were collecting, and we really need third-party validated data. So this led us to partner with SAIT to launch the largest study of its kind, graciously funded by SIREA. 30 homes equipped with wireless switching and 30 homes equipped with conventional switches to quantify the amount of wire, materials, and labor needed for both a conventionally wired home and a Levven-equipped home. The project objectives were quantify the amount of wire, materials, and labor needed for both conventionally wired home and a sustainably wired home with Levven. Complete a comparative analysis to determine the embodied carbon impact of wireless lighting and power controls, and complete an operational energy comparison to determine the ongoing environmental impact of using wireless switches over conventionally wired homes. Now, I wanted to show you this. Here's a comparison example. The first picture is the front door of a wired switch rough-in. The second picture is the front door of an identical home roughed in for Levven controls. Notice in the wired home that a stud has literally been cut out of the wire and all those wires running to it. The home roughed in for Levven controls has none of that. And I share this because it shows a stark contrast between a conventionally wired home and a Levven home. The other benefit is one of the key outcomes a builder is looking for, which is improved build quality. I'll now turn it over to Tyler to talk about the project hypothesis, challenges, and progress to date.
Thanks, James. I'm just going to do a quick introduction to GBT, Green Building Technologies. So like Kat had said, my name is Tyler Wilson. I work at SAIT in the Applied Research Department for the Green Building Technologies Research Group. I work as the principal investigator for smart building management. So I mostly work with companies developing new and innovative building products, mostly mechanical systems. So we'll work to either demonstrate or help them improve and prototype and commercialize their products by integrating them into our building, putting monitoring on them, and help to improve and give recommendations for their product. So the Green Building Technologies Research Group works with industry partners and students to help develop new products, technologies, and processes. Our goal, shared with industry and students, is to enhance the commercialization of green technologies in Canada. So we're looking to fundamentally change the way that we build, educate, and develop skilled labor. We have 5 research themes. Net zero, the first one is net zero energy and energy positive design. And we have building integrated renewable energy, smart building management, architectural ecology, and materials and advanced component assemblies. Next slide, please, thanks. So the hypothesis here is that wireless switching reduces emissions and embodied carbon over conventional wiring or conventional switching. So not only can wireless switching improve build quality and homeowner experience, but embodied carbon can be reduced at a large scale. So economies of scale when we're looking at production builders, if 200 houses are installing these, that's a lot of wire saved. 2 main comparisons are being made in this study. One, we are collecting materials data from both conventionally wired and wireless switched homes. For every home in the study, we keep track of all the wire and boxes being used. How this goes is at the beginning of the electrical rough-in, we weigh all the wire reels that are brought in. And as wire is moved in and out of the house throughout the day, because electricians aren't just usually working on one house throughout the day, they might go off to service calls or something like that. We keep track of all the wire that goes in and out. And at the end of the day, we weigh it again and keep track of the reels that leave the home again. And we do this every day that the electricians are at the house. So this gives us a fairly precise measure of wire and associated electrical materials that go into the new builds. So the second comparison that we're looking at is operational energy savings and cost comparisons. So we're installing energy monitoring in these houses. And the idea is that research has shown that if people are aware of how much energy they use less. So if they have some sort of dashboard, if they're reminded of in more or less real time how much energy they're using at a time, they're more inclined to use less energy. So we're estimating up to about 41 tons of CO2 equivalent emissions can be reduced just from energy savings when looking at 200 homes using wireless switching. This is just a representative number for a residential development. SAIT and Levven also partnered on an NSERC grant to explore a life cycle assessment of the Levven product line and analyze embodied carbon and other environmental factors that go into Levven's switching technology. So we'll compare that with the conventional switching technology and get a whole view of the installed materials, but also the manufactured materials. excuse me, we're also looking at embodied carbon emissions. Those are still being estimated, but the results from the LCA, the life cycle assessment, are going to be used in the analysis as part of this study with SSRIA. Next slide, please. So the challenges and lessons learned. We partnered with 3 builders on this project, 3 production builders, and they have homes spread across Calgary and Edmonton. So we're looking at a comparison of 30 houses with the Levven switching and 30 houses with conventional switching. So I'm just going to speak to the bullets on this slide. So one of the challenges we had was resistance to change. Electricians are all typically doing the same actions with relatively similar products in residential builds. Any variation is likely just kind of the sequence of actions that they do it in. With wireless switching, it can be pretty frustrating for them to pick up a new way of wiring a home, and having to switch between doing conventional houses and wireless houses, wireless switched houses, sometimes more than once a day. So we found that there was a bit of resistance to change, a bit of frustration with the electricians, especially when they're busy and they have to go and do service calls, and they're just juggling the multiple installations. And second was the training of the trades on the Levven product or the wireless switching product. So Levven has a pretty awesome suite of for learning the details of wireless switching as it pertains to managers, trades, homeowners, builders. They have tailored learning for each of those professions. So we found that with numerous electrical companies being involved, the 3 builders being involved, and all the houses being split between 5 or 6 developments on top of that, the training was a critical way to make things go smoothly and have everyone on the same page. But training wasn't always completed. There was many electricians involved, and not all of them got the message to do the training. So we found that was a main issue that came up when there was frustration around doing the wireless switching or around this project, was they weren't trained on the product, so they didn't quite understand it. The third challenge and lesson learned was scheduling of identical homes with identical crews. So to draw a respectable comparison between materials and labor of conventional and wireless switching homes for this study, the homes and the crews needed to be identical. If we're going to draw a comparison, everything has to be the same. This was difficult because the builders and electricians, rightfully they prioritize their clients and their customers, but with a limited building stock for our study, this became an issue. There are only so many models of homes that we can get a pair of. So if there's a certain model of home and we want to do a comparison on it, we're kind of at the mercy of what customers are buying. If there's only 2 homes being done that are identical and we have a scheduling conflict, then we have to go and we have to find a new set of homes to complete that comparison. And lastly, COVID causing supply chain issues. I'm pretty sure everyone's probably sick of hearing about this, but it did play a big part in it did offer up a lot of challenges, especially with the builders. If they don't have product, they can't move along their build schedule, and that changes our scheduling. And with the homes being in Edmonton and Calgary, that made it difficult to schedule around. So one more thing that's not on here is it was kind of uniquely difficult for this study because our team had to be there before the electricians arrived and leave after the electricians left. We had to be there every minute, or we have to be there every minute that they're there, so we could accurately capture the data that we need do the study properly, to do the comparison properly. So having homes between Edmonton and Calgary and sometimes having spontaneous schedule changes made things pretty difficult. Next slide, yeah. So progress to date. A progress to date can be broken down into these three areas. So the LCA comparison, the life cycle assessment comparison, that's the NSERC project that we're partnered on. The outcome of this study will be integrated into the reporting for the SSRA study. So far, we've developed preliminary quantities of labor and material savings based on our project home comparisons. We've vetted the toxicity of the ingredients of over 85 individual parts for, this is things like wiring, circuit board components, and everything that goes into the manufacturing of these products. We've investigated end-of-life options for Levven and conventional components and developed preliminary recommendations for sustainable product design considerations that Levven can pursue to improve their outcomes. 2, the installation material savings. So we've looked at, or we've completed 34 homes. So we've collected material and labor data on 34 homes. So we're currently adding that and tabulating that data. And we have 31 homes with monitoring systems installed. So we're just over halfway complete to the 60 homes. And 3, the connected homes. So now that homes are being occupied, we're working with the builders and homeowners to get them connected to the cloud so we can collect comparative operational data. And next slide. And I'll pass that back over to you, James.
I wanted to just share a quick dashboard of some of the reporting. So this is an example of the first dashboard that we developed, showing us how many homes and devices are connected. Reporting will be expanded to show operational use dashboards as well as uptime and other data suitable to the project comparison. And with that, I'll turn it over for questions and answers. Kat, would you like me to unshare my screen so that everyone can see each other here?
Sure, that'd be great.
Okay.
Thank you very much, James and Tyler.
There we go.
If you have a question, feel free to just unmute yourself and join. And if there's no questions, I'll start in a moment here.
So my first question is for James. James, how available are your products right now? We are going into grounds next week with a show home that we're building in the Devon area. And I'm very intrigued by your products and am considering incorporating them. How available are they?
Yeah, products are available right now. We have stock, we have inventory of most of the of everything. The biggest challenge in that timeline, Bob, is that we would want to take you and your trades through validation process first and then training, because if we skip those processes, I don't know that you would be able to fully see the value that comes to the builder, and that transparency of value is really important in our model.
Okay.
But we would absolutely love to work with any builder that is keen to get started.
Maybe James, you can pop your contact information in the chat. So if anyone wants to reach out.
Sure.
I already have.
Oh, good. Oh, good.
The email is sitting in your mailbox.
Perfect. I'll get it on. I'll get it on to my team here for sure. Chris asked a question: what is the battery life on the switches? Great question, and one that I think is absolutely important. When we first started looking at this, switching technology in our industry had battery lives that were less than 2 years. One of the real innovations that our team developed here is we had to, and which is why we ended up having to design on our own chip design, our own software stack, firmware stack, and everything for two main reasons. One of the reasons was security. And the second reason, and I can talk more about that if you're interested, but the second reason was battery life. So we've expanded the battery life on our switch, that the battery will last as long as the normal lifespan of a CR2032 battery, which means you're looking at somewhere between 8 and 12 years of life. Yes, David.
Yeah, thanks, James. I was just wondering what the energy modeling or energy monitoring system that you're using is, and if it's your own system or somebody else's.
No, it is a E-Gauge system manufactured in the US. We selected that one for two particular reasons. One, Tyler and his team have worked with it before, so getting the data off of it was easier for them. And two, it had enough outputs that we could work with the builder to decide how many different outputs they would like to monitor. Whereas a lot of these gauges that you'll see out there today, they may only have two outputs or two clamps for input. The E-Gauge one allows for up to 15 inputs.
Okay, great, thanks.
Sure. Any other questions?
I told you I was going to ask all my questions.
I want you to, Bob. I'm excited about it.
I noticed in one of your slides that you showed various connected homes. Does that imply that all the data is being streamed to you from every home that's connected, or just from those ones that are a part of your project?
So we are able to see data from our devices on all homes that are connected to us right now. And the main purpose for that, Bob, that data all stays internal. We do not share that data. But the point being is we're looking at that data to look for opportunities to help improve the user experience, improve the quality and the performance of the system, and be able to, in the future, give homeowners pointers or tips on what they might be able to program into their home to improve their operational efficiency. But we also see some really great opportunities where we could collect data and see patterns that might help builders build homes that are more usable for their customers. Because if you think about it, for the first time, you now have this entire control layer in a home visible and digitized, whereas before that's never been done. The closest thing we have to that is, say, a smart thermostat, which is really maybe one in your standard home. It's typically one data point. In ours, you'll have 70 plus devices in the average home.
Okay, so, and forgive me, I think you'll appreciate my comparison.
Sure.
Like Microsoft, is there an option to opt out of sharing that data? I appreciate your reasoning for wanting the data for your research.
Yes.
But not every homeowner would want that.
Yeah, fair statement, Bob. Today, we have to build in some more capacity in our system to allow us to create that opt-out option. Right now, it's still relatively small, so we haven't been able to do that yet, but it is on our product roadmap. The other thing that you can do today is you can run your system offline. It's been like that since day one. You only have to connect to the internet to get your registration and setup, and then you could actually have your queue connect to your phone through your personal Wi-Fi network at home. And you wouldn't be able to connect remotely, meaning if you're away from home, but you could have your home operate fully offline. That's already available today.
Okay, so that's essentially an option that can satisfy those who might be
Absolutely.
reluctant to share data.
And Bob, we spent a tremendous amount of time looking at security around this, because we're not just one device, right? We're 70, 100. In some homes, we've got 200 devices. So security is absolutely paramount. When we started developing this product, we designed security protocols that are 2 levels greater than most of the IoT devices that you can go down to the store and buy today. And the first being, we use a special crypto cipher technology that embeds that crypto cipher in our technology right here at our plant. So people can't spoof or create counterfeits and link them into our system. Secondly, we use obviously 128-bit encryption for all wireless message traffic. And third, we require to group devices into the group in the home, we require physical proximity, meaning you got to press buttons to bring new devices into the system manually. And people, when we first looked at that, my team was like, well, that's not as convenient, but physical proximity is by far and away the highest level of security that one can deliver. And that's why we did it that way. It is an operation that only has to be done at the beginning. And we've actually developed a provisioning system here at the factory. Builders can custom order the home the way they need it. We can build and provision the kit, group it all together, and ship it out to you exactly the way that home is going to be wired up, and you don't have to worry about your electricians having to do that work.
Okay, I'll let others ask further questions.
If there are other questions, yeah. Zach, you have a question?
Yes, I have 2 questions actually. Hi, James. I'm
Zach.
just wondering, the first quick question I have is for retrofit, or I'm thinking more for commercial buildings, retrofit for commercial buildings. How difficult is it to put switch out the traditional switches and put Levven switches in there?
Yeah, so I think you'll find it incredibly easy. I mean, because the wiring is already there. Most people would be able to wire a load controller into the local switch box and pair up switches and mount them on the walls or wherever, and they're done. The big issue you're going to have is when you start getting into commercial, and one of the reasons we focused on residential first, when you start getting into commercial is the ranges, right? If you want to have, like, our switches will go quite a long ways. We get about 250 feet transmit power. But once you add walls and steel studs in there, that's going to get reduced. So for operating switches in rooms and on floors, and for smaller commercial projects, I think this, our product is ideal. When you start getting into bigger projects, we're already working on the next generation of radio design, mesh routing systems that will allow for that, but that's not where we are today. Does that make sense?
Yes, thank you. And I have another question.
Sure.
So we do smart shadings, smart window shadings, and we also partner with the SAIT, and our shades are also installed at Tyler's building. And one thing that I'm thinking after I learned about Levven switches, that lighting and window shading probably makes up the indoor light management system.
Yeah.
So we are thinking, because right now one of the things we want to tap into to see every time when people open and close our shade, are they turning on their light or not?
Yeah.
Is there a way that we can collaborate and we can coordinate our data gathering so that we can see, hey, when somebody closes their shade, it gets dark in the room, they may turn on the lights.
Yeah,
and
curious, do you connect using Wi-Fi, or do you have your own bridge?
We use Zigbee, and then our
Zigbee?
Zigbee hub are connected to the Wi-Fi.
Got it.
Mhm.
And so it'd be something we could take it offline, Zach, and talk about it. It sounds to me like we would need an API developed, but yeah, there would be some interest there because I really have no interest in making shading controls. And partnering would just make sense. Yeah.
Yeah, thank you. I'll definitely reach out, and we can follow up.
Awesome.
Thank you.
Great. Any other questions? Bob, we'll wait one more second. I think it's the floor is yours.
Okay. What about RGB lighting systems, LED lights that are RGB?
Right. So we don't build a lighting control per se. We build a power control. And by that, I mean, it does not really care what the output is. So if you wanted to have RGB light bulb inside there, it would function just like a regular light switch. And then you would use your external device to control the RGB on that. Getting into lighting itself is an area that we would not be able to compete. I mean, you're going up against the Philips of the world. So we decided to go into the infrastructure as opposed to the individual bulbs and stuff.
Fair enough, makes sense. And a curiosity question.
Sure.
Would I be correct in thinking that your current limit is 254 devices in a home, or can you actually spread across a Class B?
Right now, it's about 254 devices. Yeah.
Class C.
But to be honest, we've done some pretty large custom homes, which I didn't expect because we really designed this product for, production builders. And we've had quite a number of custom home builders that want a solution that's inexpensive and simple, as opposed to a much more robust or complex system like Control4 or something like that. And I've got 220 devices and it's working great.
Wow. If there's no more questions, I might actually take a moment to share your guys' project page that we have up on the SIREA website. So I have my screen up now, if everyone can see it. So on the SIREA webpage, we have landing pages for each one of the GBTN projects. So you can go on here, and after this webinar, we'll be posting the webinar here as well as on our webinar page. And you can go in and find out more about the team. We've done interviews with both the lead, with Levven and with SAIT, the collaborators. So you can click on, and there's a few more questions that have been asked that can be further investigated there. And this is where we'll be sharing kind of the project innovation. You've seen some of the video and images today, and as well as we go through and the milestones are completed on this project through design and monitoring, we'll be posting different information up in the document library. So you can find out further what the challenges and successes are as the project goes on. So I thought I would share that and just give everyone an opportunity. If you're here today, it means you have an invested interest in this particular project. So that's one way to keep in touch on what's going on. If that's it, we might actually close up a bit early and people can have a few extra minutes to their lunch hour. Any other questions? Thank you again.
Thanks
James
very much,
Tyler.
everyone. Appreciate your time and your interest in this project. I'm excited to see the results. It's taken longer than Tyler and I expected. We thought we would be through all the homes already, and as you can see, we still have a fair bit of work to do to finish installation. COVID has definitely had its challenges for the construction community. So,
yeah.
Thanks, everyone.
All right.
Thank you
Goodbye,
all.
everyone. Thank you. Take care.
Bye.